feature of our environment, green has become a hot word in the building community. Hi, I'm Ian Story, and for my senior project, I decided to figure out exactly what it means to build green. I chose this project because I'm interested in architecture as a profession. I wanted to explore building an actual house, see what that process was like, see if I liked it. And I chose green building because of a house I saw when I was visiting relatives in Arizona. It was a exhibition house to show off some of the principles and the manners in which the efficiency of a house can be increased. And the concepts really intrigued me. They're simple and incredibly effective, and I was wondering why they aren't implemented more often. So I decided to learn more about this to see if I can answer these questions. Alright, so my goals for this project were first to learn about green or environmental design, find out exactly how it's implemented and what the benefits of it are, and how I could apply it to a house that I designed. I also wanted to learn about architecture in itself and how an architect goes about designing a house. So once I learned these, I wanted to apply what I learned, design my own solar house, and learn AutoCAD so that I could draft it in a professional-looking manner. And then once I was done with the whole thing, I wanted to go back and assess its performance and see how this house I designed compares with a conventional one. Alright, so in order to get there, it took a lot of research. That's what the brunt of this project was getting information. I found a lot of sources. I've found information all over the internet. I have two really good books for this project. One's called The Solar House. The other is Past the Solar House. They're both excellent sources and helped me a lot with my project. I also did some interviews. I got to interview an architect down in the Kirkland area by the name of Galen Page. And I also got to attend a green building seminar held at the City Hall for this, the Kirkland City Hall. Another big chunk of my work came from working with some actual professionals in the fields of architecture, construction, and engineering through a group called ACE Mentoring. This is a group of students that meets every other week, high school students interested in these fields. We get to meet with professionals, and they tell us about what they do in their jobs, and we got to work on a big group project. So I've been going to that for pretty much this entire school year, and it's been a big help with this project. I also got to, once I learned a bit more about it, I got to visit a greenhouse that was going up in the Norkirk neighborhood in Kirkland, and actually talk with the owner and look at some of what he's done in his house. So once I had learned all that, it took a lot of drafts and sketches to get a design I finally liked. So let me show you some of what I've learned. First of all, why go green? Before I get into that, what exactly is green? Well, building green is building a house in ways designed to minimize the house's impact on the environment, to reduce heat use, water use, electricity use, and to help prevent the things like soil erosion and other consequences of building. So first off, some statistics. In the United States, buildings account for 39% of energy consumption and 38% of carbon dioxide emissions. Interestingly enough, residential buildings actually emit more carbon dioxide than industrial buildings in the United States. So there's a lot of room to improve this, and that number could come down significantly if everybody implemented these principles. Let's see. So the other thing I learned about green building is it's really actually pretty easy to do. It works with almost any architectural style. You don't have to make major sacrifices in the building, and homes that are built this way tend to be comfortable, really low maintenance. They're bright and welcoming because of the way they're designed, and it doesn't have to cost any more to build them. Plus, it saves you a lot on your heating bills, which is the practical benefit of all of this. Alright, so what exactly is a solar house? Well, let me preface this by saying that any house is a solar house to some extent. A solar house operates by taking energy that's from the sun to use to heat the house in addition to some sort of backup heating. Most houses don't really optimize for this, and although the sun does affect the temperature of their house, it's not their main source of heat. The house I'm designing was really designed to maximize this potential and get as much of its heat energy from the sun as possible. It's really simple to do, and in fact, it doesn't require any fancy mechanisms, just windows in the right places. It's been around since ancient times. In fact, the ancient Greeks used it because they didn't have any of the means we have today to heat our homes. So how do you design a solar house? Well, there's a couple simple principles. First, you want to face the long axis of the house south and position most of the windows on the south side, because in order to gain heat, the sunlight has to penetrate through windows and into the house. And in the northern hemisphere, the sun is on the south side of the house. You also need to provide sufficient overhangs to prevent the house from overheating in the summer. I'll explain those in more detail momentarily. And insulation is a key to this design. You want to heavily insulate a house so that it's thermally isolated from its environment, reduces heat loss, and makes the solar gain even more efficient because you're not wasting that energy just leaking back out into the cold. The last thing you need to do is provide thermal mass, which is another concept we'll go into in more detail. All right, first off, overhangs. They operate on a simple principle. The overhangs are simply the roof that hangs down over the windows. In the winter, the sun doesn't rise very high in the sky, and it makes a low angle with respect to the building. Whereas in the summer, the sun rises much higher in the sky, and the angle is much steeper. So by properly positioning an overhang, you can allow all of the sun's light to enter into the house during the winter, warming it when you want it. And when it rises high in the sky during the summer, you can block out that light so that it doesn't enter the house doesn't overheat. Very simple principle, but one that's not often implemented to its fullest extent. Alright, so this is a simple diagram of how the solar house works. During the day, the sun streams in through the windows, warms the air, and also strikes the thermal mass, which is some sort of material, dense material that absorbs heat well, like concrete, which is what I did for my house. I used a concrete slab. When the sun strikes this, its heat energy is absorbed by the slab, and it takes a long time for that slab to come up to the same temperature as the room. So the house doesn't overheat because the extra energy just goes right into the slab. So at night, or during cloudy periods when there isn't any sun to warm the slab, that slab releases that stored heat back into the air, where it just radiates it out at its low temperature, maintaining a comfortable temperature well into the night. So on a good run of sunny days, you probably wouldn't need to turn on the furnace in this house. Alright, so a good house needs a solid foundation. This is a design that I ended up using for my foundation. I wish I could claim the idea as my own, but it came directly out of one of these books. It's a slab-on-grade foundation with a little bit of a twist. Its base is concrete H blocks that are laid end-to-end to form air tunnels underneath the house, with a concrete slab poured on top of that. There's vents cut in the north and south side of the house that allow air to circulate through this slab. So let's see, because the slab has so much stored heat energy, the air that's circulating through it draws some of that heat out of the slab as it passes through and comes up into the house warmer than when it left. So it helps to maintain a constant temperature through the house and actually harness that energy that's stored in the slab. This will happen naturally. In fact, it's called thermosiphoning, with differences in temperature produce a movement of air throughout the house. But it can also be augmented by turning on the blower in the furnace, even if the furnace isn't working. The return duct for the furnace comes right through the middle of this. It'll draw more air through and increase the airflow. And that can be blown through the ducts in the system to help increase the benefit of this even without the furnace being turned on. It also provides a secondary benefit in the summer when air conditioning is needed, because when the air is hotter than the slab and it passes through these tunnels, it gives off some of its excess heat to the slab, which is stored there. So the author of this book actually has done an experimental test house using these principles, and